So now let's talk about blocks. Blocks are used all over the place in Ruby. They're so ubiquitous that a lot of people don't even know they're using them. When they learn Ruby, they're just following the example, and they don't know that every time they say the word do, they're creating a block and passing it into a method, but that's what's happening. A block is a chunk of code. The concept of blocks overlaps. It's not entirely identical with, but it overlaps with the following set of terms. There are all lots of ways of doing the same thing, which is taking a bunch of code and instead of executing it immediately, making it in a little capsule of code and then letting someone else call it a little later. So some languages do this with something called function pointers. Some languages do this with runnables, like Java. You can't actually yet have a closure in Java, and you can't get a proper pointer to a function in Java, so instead you make an object that has a method named run, and that's a runnable, right? In JavaScript, a function is a function pointer, really. It's an object, but it's also sort of a pointer to itself. If you define a function, you can then just set a variable to point to that function, and that allows you to call it later if you want. Other terms, proc, lambda, callback, functor, delegate. C# has something called delegates, and those are a lot like function pointers. All right? So the basic idea is it's a chunk of code that you're not going to execute right now. You're going to execute it a little later, or maybe a lot later, or maybe never. Another term for what this is doing is it is rayifying code. To rayify does not mean to like send ray beams out of its eyes. To rayify means to make it into a thing. It comes from the Latin term res, which means thing, R-E-S, right? Thing. So to thingify. It's making code into a thing. Ruby has several different concepts that are very closely related, but distinct. A function, which I should really call a method, but Ruby doesn't have actual functions. So whenever you say function in Ruby, you really mean method. A method is a chunk of code that starts with def. That gets attached to a class and executed via method dispatching. A block is a chunk of code that begins with do. That gets passed into another method. And we're going to see exactly how in just a minute. A proc is actually an object that contains a block. So if you want to get a pointer to a block, put it into a variable, you can't do that directly in Ruby. You have to make a block and then make a proc out of the block and then point to the proc. It's a little convoluted. I'm going to show you exactly how that works starting in the next slide. But I just wanted to throw these terms out here. There's a subtle but important distinctions between methods, blocks, and procs. A proc is an object that points to a block. A block is a chunk of code. And a method is also a chunk of code, but with completely different calling semantics.
And is a block either starts with do or curly braces?
Yes. A block starts with do. Curly braces are sort of shorthand for do, right? And I don't like the curly braces. It would be better if the curly brace just didn't exist. Because curly braces are also used for hashes. So it's a little ambiguity in the language that's irritating. So, every time you see do, as you just previewed, every time you see do, it's the start of a block. So, fixnum has a method called times, and times executes that block this fixnum number of times. So if I want to execute this code here, there, right? I'm executing this. I'm taking this line of code, puts pip pip array. I am making it into a block, rayifying it, and then times is calling that 3 times in a row. Notice that at the moment I declare it, nothing is happening. It's the times method that is calling back and executing that code. So yes, blocks can be wrapped in curly braces. A lot of people who are new to Ruby prefer the curly braces because it just looks more like Java or C or JavaScript. Get over it. Use do end rather than curly braces for the reason I just said, which is that with the curly braces, there's some ambiguity with parsing because it could be a hash, and that leads to some subtle, annoying syntax errors sometimes.
Also, indentation is hard with curly braces.
Indentation is also, yeah, it's, well, depending on your editor. Technically, there's no difference. It's just a symbol, like do versus curly brace, it's just a symbol. So you should be able to figure it out. It's just, it's better to use do end. We're going to see in just a few more slides. It's not actually a parameter, or technically it's not a named parameter, it's an anonymous parameter. And we're going to see what that means in just a minute. But yes, it is being passed into times, just not in the normal way. So blocks are used for lots of different purposes. They're used to solve lots of different problems. The idea is that you leave it up to the receiver of the block to decide what to do with that code and when or whether to call it. So one thing that blocks are used for is callbacks. Let's say that you want to ask your networking library to read in a TCP connection, and then as soon as that connection is closed, take the contents of that, the entire packet of stuff that got passed in by your network client, and pass that into a block, right? So you're going to call it later at a specific time, but you don't want your code to wait for that to happen because it's I/O bound. It might take seconds and seconds, you know, which is like eons to a computer. You don't want to wait for that I/O to come, so you make a block and you pass that block in, and then you trust the library to call that block later when that data is available. All right? You can also use blocks for initializers, lazy initializers. Let's say that I'm writing a Sinatra app. Sinatra is a web app framework that lets you set variables. Maybe at the time that you declare your program, you don't know what the proper value is. So you make a block that will be called later, and that block will know what the proper value is at the time that it is called. All right, so it's for initializing things, but initializing them later on, not like when you declare the program, but when you're running the program. So some more stuff has been set up in the meantime. They're also used for iterators, which we've been using a lot. They're used for separating the content, the body of an algorithm, from the boilerplate around that algorithm. Loops are the classic example. The iterators keep track of initializing an index, incrementing the index, grabbing the value, and in the case of map, collecting the results into a new collection. And then after having done all that standard stuff, they call your block, and your block does the specific stuff, the idiosyncratic stuff that your particular loop will need. So it extracts common boilerplate stuff inside of a method and then calls back. In that case, just like with times, it happens immediately, but it's still a little bit later. And it still makes sense to do it. It's not a callback in the sense of waiting for something to happen long in the future. It happens immediately into the future, but it's still into the future. It's also useful for testing, like the before block in RSpec, right? You're specifying a bit of code that's going to be run before every single example spec, every single it block. By the way, the it block is also a do block. It's also a, turns into a proc. Also, it just looks cool. Sometimes your code just looks better if you do things with blocks rather than doing things in the exploded C style.
So there are also cases where looks like you can use blocks to submit your own logic to a standard algorithm, like a processor method. Like for sort, you might pass the comparator method into the block.
That's another great example. If you didn't hear, the sort routine has a standard comparison, which is to use the flying saucer. But if you want, you can pass in a customized sort block, right? The sort block would take two parameters, the left side and the right side, and then return, -1, 0, or +1. But you can do whatever comparison you want inside that block. So when you say array.sort do, you're configuring the algorithm the way that you want it. So let's talk about the proc keyword. Proc turns a block into a variable, or rather into a reference. And then you can store that reference into a variable. So in this case here, if I want to say proc do, right? In this case it's on one line, so we're using brace. But if I say proc do puts high, that has made a reference to an object that when you call that object, it will execute that block. And by call, I mean, say, object.call. So in this case, I've put it into a variable called say hi, and then I say hi.call. And that will execute this block. And of course, procs can take parameters, right? Blocks can take parameters, and therefore proc.call passes its parameters into the block. Yes, question? Yeah. Yeah, and I've been, it's a little technical, but what's happening here is proc is actually a method, or it acts like a method, and then this is the block. So this, if this is do puts high end, that defines a block, proc turns that into a reference, and then you'd say reference.call, that executes the block again. So when you say call just passes its arguments directly into the block. Make sense? Okay. So if I wanted to write a version of times that wasn't as cool, sort of a dumbed down version of times, I could do it this way. I have a method called twice do that takes a proc, which I'm naming action. Could name it anything, I'm just calling it action right now. And inside of that method, I'm calling it twice. So now when I say twice do, well actually let me spell it out. I now have a variable, say hi, and that variable, as you see, the value of that is actually a proc. So if I wanted to say hi.call, it does its thing. Or I could pass that in as a named parameter, and then twice do is going to call it twice. Right? Now, I don't need to put it into a variable if I don't want to. I could do that all in one go, like this. Twice do, proc do puts high end. Right? So this thing here defines a proc and passes it in. What's the proc going to do? Well, it's going to do this. It's going to do whatever I said in do end. All right. So now here comes the kicker. The default block. Should have been called the anonymous block or the invisible block, but it's called the default block. It is invisible, and it gets passed in just like this guy got passed in, except instead of being passed into a named parameter, it gets passed into an unnamed, invisible, anonymous magic parameter. And on the inside of the method, in order to call it, instead of saying action.call, you say yield. So if I wanted to do the thing I just did with procs, but using the default block instead, this is the implementation of that method. And now you see why I put that weird underscore do in the previous method name, because now I can say twice do puts, did that work? Yeah, let me try that again. Twice do puts high end. So this here is equivalent to this here, but this second version is much more concise and it reads more Englishy, right? It's got that domain-specific language thing going on. Here I can actually say twice do this. Yeah?
What went into twice here? Is that a block or a proc?
It is actually a block. If I had said the word proc here, that would turn it into a named parameter, an explicit parameter. But because I didn't, it turned into an implicit parameter. And this is something that's magic and built into Ruby. Now, I want to point something out. This is not the only magic invisible parameter. There's also one called self. All object-oriented languages most object-oriented languages, have a variable called this or self, and that's actually not a global. That's a parameter. It gets passed in to every function call so that that function knows which object it's attached to right now. The same thing happens here. It's another invisibly passed in parameter to every single method. Most of the time it's blank. But when you actually specify it, the value is filled in. The only difference between self and this guy is that this guy doesn't even have a name. It's not even called self. It's just called nothing. It's called the default block. It's anonymous. Self at least has a name. The name is self. But this guy doesn't. Okay? Question?
Would it be possible to define a method that takes parameters as well as a default block? Or?
Absolutely. And we're going to see that in a minute. Not right now, but in a minute. So I just want to belabor this point. Forgive me for belaboring the point, but I just want to point it out. Ruby could have worked perfectly well without invisible blocks. It could have worked just fine, except then it would look like this. Matt's decided that this code down here was prettier than this code up here. It's more concise, and arguably it's more clear. And that's the only reason why we have this weird magic, plumbing of the default block, which makes an anonymous parameter passed into every single method. And this weird call yield, which really means default block.call. Right? It's just to make the language look nicer. And there are other reasons for that as well. Like there are certain ways in which we've now crossed some magic threshold where we can make our code look really super nice instead of just a little nicer. But right, this here, twice do puts hi. This allows us to make a method, in this case twice, that looks for all intents and purposes like it's a keyword in the language. So, for instance, if, right? If is a keyword in the language. While is a keyword in the language. And you say while condition blah 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 end. In this case I say twice do blah 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 end. It just looks like it's part of the language. It lets the language grow. Right? This is metaprogramming. It just makes the syntax for methods approach the syntax for keywords. All right? That's the reason for it. You might think that that's a dumb thing to do, but that's why they did it. Okay? Question, yeah.
So, the top one twice do,
Mm-hmm.
is it required to have
No, not at all.
so you can just make that one twice.
I could name it twice, but then I couldn't execute it in the same window. That's all. I could have named this def twice. Totally fine. I'll do that right now if you want. Right, so now I can say twice proc do puts hi end. Oh, I messed up. I need to see, this is why. The syntax gets a little weird, right, with parentheses and stuff, if you don't follow the rules. But anyway, there. That was just part of the name. The underscore do is irrelevant. Yeah.
Any function that has the word yield must accept a block?
Let me put it this way. When you call yield, if there wasn't a default block, it's a runtime error. Right? So like right now, if I just call yield, it'll say no block given. Because I'm just in... Pardon?
What if you call twice? Without
Uh-huh. Oh, well, this, I lost the original twice, but yes. Twice nothing, no block given. So if you're going to call yield, you better make sure that there's a block. I mean, sorry, a default block. So of course, the default block can accept parameters, just like any other block can. So here I say do with vertical bars rather than parentheses. So here, this is a block that takes a parameter and then prints that parameter with the string Mississippi. So here I'm saying yield with 0 and then yield with 1. And that way when I call this guy gets a 0, prints it, adds 1 to it because we want to say 1 Mississippi, 2 Mississippi, not 0 Mississippi, 1 Mississippi. All right? So here I'm yielding 0. That just means I'm calling the default block with the parameter 0. And let me show you a more advanced example of blocks that take parameters. Here I'm re-implementing each. And again, this for underscore, that's just my decision for the name of it. I didn't want to call it each because we've already got a method called each on array. But this one takes an array. So here we have a method that takes a named parameter and a nameless parameter. So when I call it, I say for each passing in the array, and then I'm also passing in a block. Notice another little syntax weirdness. The do has to be outside of the parentheses if you have parentheses. It's like a whole separate parameter list that can only have one item in it. Right, so just going through this in a little more detail, this iterator initializes an index, says while that index is less than the size of the array, grab that item, pass it in as a parameter to this block, and then increment the iterator, and then when we're done, return self because that's what each does. Not self, in this case it's the array, right? Returning the original collection is what each does. Any questions on this slide? Okay. So blocks can also return values. Just like a regular old method, they can accept parameters, they can print stuff, they can do calculations, and they can return. So here's an example of map. I'm re-implementing map on the outside of an array rather than on the inside of an array. So let's look at how this works. I initialize the index, and I make an array that starts out empty. And then for each item inside of it, I'm going to yield that item. Right? For each item inside the original array, I yield that item. And then I take the return value and append it to the output array. And then at the end, I return the output array. So in here, this works just like the regular map, except instead of names.map, it's map@names. This block accepts an item and reverses it and returns it. So this works just like array.map, except it's map of array. Questions on this? Okay, let me ask, how many people understand this? Okay, everybody's got to go in like this. That's all I can expect for 12:25 in the morning, or no, in the afternoon. In the morning, it'd be another thing. Okay, let me move on. This answers the implicit question that Roy had before, which is, what if you didn't get past a block? In the spirit of duck typing, usually you should just fail. If you're supposed to be passed in a block, and the caller didn't pass in a block, you should let it fail. Fail fast, right? Fail early, fail often is the motto of a Ruby programmer, right? You want the runtime errors to happen because that's kind of all you got. It helps the programmer, right? It helps the caller if the receiver fails with bad data. You don't want to protect the caller from himself. So in this case, I'm assuming not the normal case, but a case in which the method works with a block passed in, but it also works without a block passed in. So in that scenario, I can call a method asking whether the block was passed in, and that method is called blockGiven. And usually that's used in code like this. Instead of just yield, it's yield if the block was given. Again, this is not the standard usage of yield. You should have a reason for calling block given, and that reason should be that you know your method should work with a block or without a block. It's a decision, an actual proactive design decision to use block given. It's not the standard. Okay. Here's some relatively advanced stuff. Sometimes you want to write a method that takes in a default block, but then saves that block away for later use. In that case, you have to turn a block into a proc on the inside of a method. Remember, you can't actually store a block inside of a variable. You can only store a block in a proc and then put the proc in a variable. So this is what does that. If you say ampersand and then name a variable, that's just a magic incantation that says, take the default block, make a proc for it, and put it in the variable named p. So later on, I can store p in an instance variable or just say p.call. Remember, it's a proc, so you say proc.call. If it's just a block, then you say yield. It's a little disorienting, I know, I'm sorry. I see a couple of people's heads exploding. Sorry. This won't go on for much longer. Maybe we'll pick it up again after lunch. But this is just the ampersand turns the default block into a proc. You can also turn a proc into the default block on the other side, right? If you're a caller and you're calling a method that takes a default block, but you've got a proc, maybe it's something you've stashed away from long ago into a variable, you can turn that into the default block by using the same ampersand. It means the opposite. On the outside, it means turn a proc into the default block. On the inside, it means turn the default block into a proc. Same sense, but it's just completely the opposite. Okay. Now, I promise this is the last slide before lunch. I've been using the word proc all over the place, proc and block. Ruby has actually two types of closures. Ruby has procs, but they also have lambdas. Procs and lambdas are almost the same thing with two very important but very subtle and technical differences. The first difference is that in a lambda, it cares about the number of parameters that you pass in, but in a proc it doesn't care. So let's say that there's a proc. If you call the proc with 10 parameters, but the proc was just defined do blah 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 end with no parameters, that's fine. But if it was a lambda, then it would care. It would actually say wrong number of parameters, just like a method does. The other difference is even more subtle, which is the behavior of return. If you use the term return inside of a block, if that block is in a proc, then that return statement returns from the method that is calling it. But if it's in a lambda, it returns just from the block. And that fact there just means never use return ever in your life ever because it's too confusing. Because you're just gonna mess it up at some point in your life if you ever use return. So just don't do it. Just use if statements and then end at the very last line. Seriously, trust me. Just don't. I mean, maybe okay, in a year you can start using return again. But that's one of the reasons why I recommend not using return at all, because you might be inside of a block, and in that case, return would return from the method, or you might be inside of a lambda, and in that case, it would just return from the do-end block. And the fact that you might not know what's going on is just hard. I see you're looking at him, so he's been using return a lot, huh? Okay. Anyway. So now you might have enough information to do these labs. I have one more hint, which is the silly blocks labs are silly. They don't make any sense at all. They're really dumb. There's no reason why any real programmer would ever write functions that behave that way. The problem is it's really hard to write tests for teaching blocks. So let me just give you a hint about the very first one. There's a method called reverser. You need to write the method reverser. That method takes in a block. That block returns a string. Your method needs to call that block and then reverse the string. And then return that. So it's weird because there's just so many things going on, so many moving parts, right? The test calls your method with a block. Your method calls that block, which, oh, by the way, it's back in the test, does some stuff, returns it back to your code, and then you do more stuff to it and then return it back to the test. It's just insane. So hopefully I've made it a little less insane by jumping around and waving my hands. Okay. Everybody, any more questions before we go to lunch? Okay. Thank you.